Welcome everyone. This is a talk on polars. So if you're looking for polar bears, this is not the place to find polar bears, but we're going to be talking about how to use the data frame library polars. And if you go to that link there, I put it on the whiteboard here, if you miss it, that goes to my GitHub. I'll just show what that looks like really quick here. So it's something like this. The cool thing about this is that you can use code spaces if you want to. So you can come up here and you can click code spaces and create a code space. And then this will go out and provision everything so you can just use this and follow along if you want to. Alternatively, if you want to, you can clone this if you're up for that, and I've got the instructions for doing that. I'm using UV these days. Who uses UV? Who isn't using UV but should be using UV? Yeah, I'm not using Pit Virtual anymore. I'm all UV, so it's awesome. So you should use it, or at least try it and see if it works. Alternatively, if you're a Colab person, you can just you can click on the notebook and change the GitHub to Colab, and this will launch in Colab. You might need to install a few libraries there, but there's actually code that will show you what libraries to install with this. Anyway, that is the slides, so to speak. Okay, so a little bit about me. I like to say that I sell snake oil and teach people to tell lies with data. But I do mostly corporate training these days, so I help teams level up in Python. And I do a lot of data science related training as well, mostly around the tabular area. So relevant background for maybe this audience, like why am I teaching this, or what's going on here? So when I graduated from college, my first job out of school, way back when, was doing natural language processing in Python. This is before like NLTK or SPACE existed. Basically, we had to wrap C libraries and do that with Python. And that's actually how I started using Python. The colleague that I was supposed to work with was using a language called Tickle. And so my working, now he's jumping in now. And okay. And I had been told that if I learned this magical language called Perl when I was in school, that I would get a job. And so I did learn that, and lo and behold, I got a job. So I was in the Perl camp, and he was in the Tickle camp, and we were tasked to work with each other on this natural language processing problem, and neither one of us wanted to cross that bridge. So we met in the middle, and Python was like the nice middle ground. Back then, we had to like hide that we were using Python. So like, what is this Python thing? Luckily, it turned out to be a good choice. It sort of clicked with me, and I've used it ever since. Later on, I created an OLAP engine on top of MonadDB. So that got me like SQL Alchemy, Committer-Rice. But later on, I went to PyCon and heard about Pandas, and I saw, oh, there's all these things that are similar to Pandas in this OLAP engine that I had created for doing reporting. Then I started using Pandas for a lot of data science related things, wrote some books on Pandas, did some training on Spark, the data frame side of that, wrote the second edition of Pandas Cookbook, wrote a book called Effective Pandas, started doing some collaborations with other companies. So did some stuff with QDF, which is really cool, did some stuff with Modin, and then started playing around with polars. Ended up writing effective polars, and some of the people in here will be happy that there's a company called NVIDIA that is doing some good work, and they have a polars backend as well. So I'll talk a little bit about that. So that's kind of been my journey. I tend to focus on the tabular side of things. I know that like generative AI and deep learning are very cool and sexy and do fancy things, but I feel like a lot of people, their crown jewels are sitting around in Excel or SQL. Does anyone have that experience? No? Some people? Okay, some people feel that way, yeah. I think that like a lot of there's a lot of low-hanging fruit in tabular data, and people are like, oh, I need to use deep learning, or I need to use AI, but they have all this stuff that they could access, they sort of skip over. So a lot of my stuff is helping companies sort of extract value out of that. So everyone here knows that Python is slow, probably. Hopefully, if you didn't, I'm sorry to inform you that Python is slow. And even yesterday, there was something on Hacker News about how the GIL is getting removed, and there are all these arguments about how Python is fast now. And really, Python isn't fast, it's a slow language. Generally, how people have gotten around this in the past is they've written things in a fast language and then wrapped it with Python. And that's probably the reason why Python is so popular. In fact, I would tell you, if I could blame my career on someone, it would probably be Travis Oliphant, because I think because of NumPy, I have a cool job doing what I'm doing today, because I think if NumPy didn't exist, probably this conference wouldn't exist. And we could probably trace that back to that. So traditionally, pandas, it might be like, Python is slow, why are people using pandas? And again, the dirty secret is that well, it's using a lower level library that's faster, right? So the NumPy for pandas 1 gets around that. PyArrow 2 improves on NumPy to get around that. And so this isn't about pandas, but who in here uses pandas? Okay, awesome. Who likes using pandas? I like pandas, right? I mean, I've used it for a long time. It kind of fits my brain. It works with almost everything, so there are good things about pandas. There are also bad things about pandas. Okay. Who here uses polars? Okay, a few people use polars. Awesome. So we've got a few people who, it seems like almost everyone here is using pandas. I'm going to make an assumption, you can tell me if this is wrong, that you're in here because you're using pandas and you're like, I've heard about this polars thing and I want to know what the difference is. Or should I throw out all of my pandas code and move to polars? Is that maybe a safe generalization? Well, okay, awesome. Okay, so hopefully I can compare and contrast some of these things as we're going through this, because like I said, I've worked a lot with pandas and helped a lot of companies with their pandas code. So again, Python is slow, and if you're processing large amounts of data, we can use Python, but we need to kind of stay inside of this sandbox, right? And the sandbox is the lower level libraries that's doing things in a fast way. And oftentimes we have ways to get out of that sandbox, and that might be useful in times, but oftentimes when we get out of the sandbox, we're slow. Okay, because like NumPy, if I represent an array of 1 million integers, right, it's going to make a buffer that, if it's 8-bit integers, it's going to make an 8 million bit array in memory, right? And we just have a Python object that points that whole thing. Whereas in Python, if I make 1 million integers, each integer takes like 28 bytes or so to represent, and so you have a huge amount of overhead with Python just by using Python objects, right? So Python is flexible, but that overhead causes memory usage and also makes it slow. So we get around that by using things like NumPy or PyArrow. And again, polars gets around this by being implemented in Rust, and then it has an implementation of Arrow. It's not the same as PyArrow, but Arrow, if you're not familiar with Arrow, Arrow is an in-memory representation meant to represent tabular data in a specified way, such that if I said, here's an Arrow blob of data, and I have some other tool that speaks Arrow, I can point the other tool and say, here, point at this, and essentially what I can do is I can do something like this, where I can say, load my data in pandas, pass it to polars to do some processing, pass it to DuckDB. Polars and DuckDB both speak Arrow, and I can do a 0 copy pass of those, and then put it back into pandas if I want to, without copying the data. So that's what this Arrow thing gets us. But also, Arrow, in the case of Arrow in the case of PyArrow or the Rust implementation, also have operations that can work on these pieces of tabular data. Okay, so just as far as the presentation goes, if you have questions, feel free to raise your hand during, and I'm happy to answer questions during. We'll also have time for questions at the end. So I'm just going to load some data, and I'm going to kind of simulate what I would do if I was working with a client or if I was working with some of my own data, some of the things that I would do with my data, and along the way, hopefully dispense maybe some wisdom or some tips and some ideas for you to think about if you're thinking about using something like polars.
Let's see.
Okay, so again, polars. There is a Rust library that implements polars, and then there's a Python library which you can think of as a veneer on top of that. Polars does not implement the Pandas API, so if you're thinking that like I can just take my Pandas code and change my import Pandas as PD to import polars as PD, you're going to be disappointed. That's not going to work. Polars also has this notion of a context and an expression, and that's also different from Pandas. And if you think about this, Pandas, when it was implemented, kind of ignored the fact that there's like 40 plus years of like relational database technology that came out, that if you like squint and look at like operations that you do on a data frame, they're very similar to what you do with a SQL table, right? And we've got like all these technologies that have like matured and added things like query engines of that over the years. And Pandas was just like, no, if you need to do something, I'm just going to naively go out and do it, right? And so it's eager, and it went out and did things. And so polars kind of remedies that. It's like, okay, we do have, like I said, a history of ways of dealing with tabular data. We should probably like think about things. And is Richie in here? Okay, so the creator of polars is somewhere around here. I heard a rumor that he might be in here. So I can't deflect all the questions to him, but I've heard him describe polars not as a data frame library, but as a query engine with a data frame library on top of it, right? And you couldn't, like it'd be a hard sell to sell Pandas as a query engine. Okay, it's a data frame library, but it's not really a query engine. And so at a high level, there's these things called context, and you can think of context as operations that would give you a table or data frame back. And then you can think of expressions as operations that you build up, but these operations don't refer to the data themselves. They refer to like this concept of a column and operations that you would do to a column. So I can say something like this, like PL and then column name. This, in Pandas, we would do something where like we're saying, this is the series, right? This is the column. We're going to pull out that chunk of data and we're going to manipulate it in Pandas. And in polars, we don't do that. We say, here's the column name. This thing that is a table has a column that's named that, and I want to do these operations, and then we feed these operations into a context, and the context has a smart to run the query engine and basically materialize this in a smart way to give us the results that we want. Okay, so it is lazy, or can run lazily. Again, it does have a query engine, and then again, going back to that conversation, like Panda or Python is a slow language. When Python came out, most people had one CPU. Now that seems weird, but that's how things were back in the early 90s. And because of that, we have the global interpreter lock, and so that's kind of stuck with us. Anyway, Polar sort of throws out that and says like, okay, most people have multiple CPUs, so let's do smart things where you can have like a queue per CPU, and when we have to do things in parallel, we just throw them onto these queues, and if one of the queues exhausts, we can like move things over into another queue and make good use of our CPUs. Okay, so let's load some data here. Is there a Jupyter developer in here?
Okay, all right.
Okay, So I'm going to load some data, and this data is personal data for me. So what is it? November. So 2 months ago, almost exactly 2 months ago, I found myself in a weird situation that you don't necessarily want to be in, where I was flying through the air, and I knew that that was not a good flight. So I live in Salt Lake, and I'm a coach for a mountain biking team, and I was sweeping the ride. So the sweep is the last person on the ride. They go after all the other people, and they kind of like pick up the trash or people who crash or whatever or slow. And it turned out that somehow I was going over my bars. I was the one crashing, right? And so I don't remember a lot about that day. I remember crashing. Well, I remember flying through the air and looking to my side, and I saw the person in front of me, because we were on the switchback going through, and I was like, I hope they hear me crash, so they'll like stop, but that didn't happen. The next thing I remember is like waking up and pulling out my camera and taking a selfie, and I'm not going to show you the selfie here, but I was like, I want to see how many teeth I lost, because basically I landed on my face, and like, anyway, we didn't talk about the gory details of what happened. So I got up, took this selfie, and then somehow I made it to where the rest of the team was. They're like, oh, we've been waiting for like 5 minutes for you. And then they're like, we should probably walk out if you aren't in such condition to ride. They're asking me all these questions, and it's like, I was in this really weird, I had a concussion, and so I was like in this really weird state of mind. And they're like, I told them I wasn't coming to the ride on Thursday, and they're like, why aren't you coming on Thursday? I'm like, I don't know why I'm not coming. Like, my brain wouldn't work. And then like 5 minutes later, as we're walking down the mountain, I'm like, oh, I remember why I can't come on Thursday. It's my anniversary. And they're like, oh, okay, well, you won't be kissing your wife with the current state of your face, how it is. I'm like, okay, well, that's nice to know. Anyway, so my goal here is I wanted to find out like how long I had been on the ground there without anyone around me, because they're like, we waited here for 5 minutes. I'm like, was it really 5 minutes? And I didn't. So I did have Strava. Anyone in here use Strava? Okay, so I had my ride recorded on Strava. So I've downloaded my ride, and this is the data that we're going to look at. We're going to look at Matt's faceplant Strava data. My goal here was like to see if I could figure out like exactly how long I was knocked out. So I'm gonna basically walk you through this data set and kind of, again, show you the process that I would do if I was given this as like a client asked me to work with it or to do some data analysis on this. And so, again, we're going to use Polars, so you should install Polars. If you're using the code space, you don't need to do any of the installation. It works. There's this GPX library. That's going to load the GPX file, which is the file that Strava gives you. So we'll just run this import here. If you're using Cola, you need to do that GPX file. Okay. Yeah.
Why not use UV to install Polar?
The question is, why not use UV to install Polars? Yeah, I actually did use UV to install it, and if you're using CodeSpace, it does use UV, but yeah, if you wanted to, you could say UV add Polars or whatever. You can also say UV pip install if you want to this problem.
Okay.
Yeah, but if you follow the instructions on my line, it's all doing UV under the covers. So, okay, other questions? Okay, so I'm importing this GPX library, which loads these XML files. We got NumPy in there as well. We're loading Polars. We're aliasing that as PL. So you don't have to alias that, but that's like NumPy, NP, or Pandas, PD. There's also the selectors module. This is a module that allows you to pull out columns based on properties of the columns. So we're going to load that, and we'll load Pandas as well. So I'm using Polars version 1.12. So this is probably the first thing to, well, one of the things to note if you're using Pandas versus if you're using Polars. It's said that a lot of companies like boring technology, and Pandas at this point is kind of boring technology, right? It's sort of been around for a long time, it's kind of standardized, it doesn't really change quickly, and a lot of companies like to build on that because they don't want to come to their code in 2 weeks and someone updates the library and everything breaks, okay? So I'm using Polar's version 1.12, and Polar's is a little bit different. Polar's has a lot of releases, right? It probably releases, I don't know, every month or 2 times a month. Okay, and it's not that necessarily every one of these releases is breaking something per se, but it does have a much quicker cadence. And so that's good if you like have some issue and you're like, hey, this doesn't work, and the Polar's developers are actually really responsive and they're like, oh, we fixed it, it'll be done in a week, right? But it's not good if you have all this code, you got a million lines of code, and then an API changes and you need to go in and change all that, right? That's kind of not good. So, and again, I'm not saying that Polar breaks everything all the time, just be aware that it is like a fast-moving library. Okay, we'll just run this code here. This is just parsing the GPX file. I'm not going to go over this because I don't think it's super, as far as parsing, it's not super interesting probably. But if we look at the data here, this is what we pull out of this. And a couple things just to note. Like if you are, if you're used to Pandas, right, if I just pull up the data frame, this looks very similar to a Pandas data frame, right? I mean, if you look at that, oh, that's a Pandas data frame in Jupyter. Well, it's not quite. If you notice on the left-hand side in Pandas, when we print something out, we have this thing called the index, right? And that's the thing that's in the left-hand side in bold, and there's nothing that's in the left-hand side in bold here. There's no index in Polars. So that is what it is. It's a design choice that they made. Pandas has the index, which can be nice for aligning certain things before doing operations, but a lot of things, like a database doesn't have an index. Well, a database might have an index, but that's a different index than the Pandas notion of an index. So there is no index. Otherwise, it looks very similar to Pandas, other than like below the column name, it actually tells the type of the columns, which is kind of cool. You don't have to explicitly ask for the types as well. But we've got like, okay, this course thing, how far I've gone in 2 dimensions, latitude and longitude, time looks like every second or 2. And then what our elevation is, I believe that's in meters, and then the speed between 2 points, and then how far we've traveled, and I believe this is the elapsed seconds, and then the average velocity, and then like we've got some rolling values in there as well. Okay, if I look at this, I can ask it what size it is, and it says that like this is like 1.09 megabytes. So this is not large, big data by any means, this is small data. And maybe I'll make a comment about that. I generally, when people ask me like, where is Pandas sort of fit in? And I generally say Pandas, the library, is a small data tool, where my definition of small data is data that fits in the memory of a single machine, right? And there might be, I can't say what size that is because it's possible to rent a big machine that has a lot of memory in it, right? And it's also possible to have a laptop that doesn't have a lot of memory. But for Pandas, to work with Pandas, you need to have all your data in memory. So Polars, I would describe it as a medium data library. And my definition of medium data is that it fits on a single machine, but not necessarily in memory, right? So it might spill out onto disk. And Polars does have a notion of streaming, where you can have stuff on disk and then pull that in, and it doesn't all have to fit into memory. So if you're using Pandas and you're like hitting into this memory issue, maybe Polars might help solve with that. My gut would be like, if you're running into memory, you should do some other things with Pandas before like throwing out the baby with the bathwater, like getting a bigger machine, or making sure that you can maybe compress the data or maybe even sample the data. Now having said that, there are other tools that either use the Pandas API. So when I say Pandas, the library, that's the pip install Pandas. Other tools that use the Pandas API that allow you to scale out to data loads larger than a small data set. And some have better, say, library compatibility than others. Like some, you just change the import and it works on a cluster rather than on a single machine. Okay, so let's, if you want a row index in there, you can do this with row index, right? And this doesn't make an index per se, but what it's going to do is it's going to make a column that's called index, and it's just a monotonically increasing number there. It's going to stick that in if you want that. Okay, so this is our basic data frame here that we have loaded from this XML file. Okay, so generally when I get a piece of data, oftentimes I'm working with CSV files, but you could be working with Excel or SQL or Parquet or whatever. I just like to look at what the columns are. So you can ask it what columns are, and this is very similar to Pandas if you're familiar with that. And so I'm just going to make a variable here that has the columns that I want. And then, similar to Pandas, I can actually pull off those columns here doing this index operation like that. And then I can also ask explicitly what these types are. And note that this is not, in Pandas, this would be a series, right? In here, this is a Python list. It's just, here's a sequence of each of the types for each of us. Now again, note that like that float 64 is not a Python float, right? There is no float 64 in Python. This is this arrow representation, and it's like allocating a buffer of memory that holds 64-bit floating point numbers and doesn't have the overhead of Python for each of those columns. Okay, and so again, that size is 1.09 megabytes. Again, this isn't a huge data set, but oftentimes by making sure you're using the right types, you can shrink that down considerably here. So one of the things that especially if you're using something like CSV files, when you read something in, CSV files tend to be human readable, and that's kind of nice that they're human readable, but that's like the end of the good things about CSV files. They don't have type information. They don't have ways of partitioning them, so they're not necessarily the best choice. And these tools might read in a file that has a bunch of integer columns and store them as 64-bit integers, where you don't need 64 bits to store all of these. So I'll often go through my columns and just look for the integer columns and make sure that they have the right type here. So in this case, note what I'm doing here. I'm saying df columns to limit the columns, and then I'm doing a select here. So select is this thing called a context, and then we're going to pass an expression in there. I'm going to say PL column, that makes an expression. And note that I am passing in a type in here. I'm saying it in 64. So what this is saying is I'm going to pull out 64-bit integers and call this a 64-bit integer, and we see this result right here. Okay, so this is the elapsed time in seconds. And does this need to be 64 bits? Maybe. Similar to Pandas, there is a describe method here, and when we do that, we get something again that looks kind of like Pandas. No, again, there's no index here, but it sticks in this statistic column here, and it gives us the count, the null count, the mean, standard deviation, minimum, maximum, the median, and the quartiles there. Now, one thing to realize in Pandas land, count really doesn't mean what most people think count means. In Pandas, count means the number of rows that aren't missing values. In polars, count means the number of rows. So this is the number of rows here. Looks like there's 10,430. Pandas has a null count, and this is the number of values that are missing. Null count is 0, indicating that there aren't missing values in there. So kind of nice that it just gives us that little teeny bit of extra information, especially if you're doing something like machine learning, where a lot of libraries don't like missing values. Okay, so I wrote this like this as one line of code. It works fine, like this runs, but often, I come across people at work and they say, I'm not a programmer. And they say, I don't want to be, and they also say, like, I don't want to be a programmer, right? But the odd thing is like, they're not programmers, they don't want to be programmers, but they're sitting in front of like Jupyter all day, typing in code, but they don't want to be programmers. So I take it as sort of like, okay, you're not a programmer, that's fine, but I'm going to covertly kind of give you some best practices and some hints to make it so you start doing some of these things that programmers would do. And one of my opinions about coding is that you should write code that's readable, right? And I would put a caveat on that with maybe an asterisk. It should be readable to a specific audience, okay? And then maybe I'll give an example. So here's another thing. I'm going to show you a bunch of code, especially like, I don't know, for whatever reason, I throw code on social media and people like get really upset about the code. And I've had people say like, that's the worst code I've ever seen. I would never work with you. I would reject this PR if you submitted this PR. And generally I'm like, okay, at this point I'm an educator. My goal is to help people write better code. I'm happy to like learn how to do it better. Tell me how to do it better. And generally it's crickets at that point. They don't have a way to do it better. They just don't like what it looks like. And I think some of that is like they're not used to that style. But also some people say like, well, that's not readable for a beginner. And my goal is not to write code that's readable for a beginner. When I'm in a professional context, I want to write code that's readable to a professional. Right? If I'm catering it to a beginner, I can miss out on a lot of best practices or optimizations. And so I want to write code that's readable for a professional generally when I'm using code in a professional context. And hopefully, instead of like catering to the lowest common denominator, I can help those people at this beginner level up their knowledge and understand how a professional might do things. So one of the things here, like this code is fine. Well, I mean, it's not, well, some people might claim it's not fine, but it works, okay? But I can do a simple just rearranging of this code by putting parentheses around this and then putting each operation on its own line. It's the same code, but what this does, and we call this chaining, what you do when you like call multiple methods after another. Very common in Pandas and I would say almost required in polars. We'll talk about why in a moment. But what this does when you format it this way, you put parentheses around the start and the end. Inside of a parenthetical in Python, you can ignore white space, okay? So we don't have to worry about indentation rules or white space rules. But what this does is it forces me to look at this as a recipe. And I can see, here's what I'm doing, and I can come in here and I can comment this out if I want to. I can say, okay, here's our data frame, right? Whoops, don't look at that. Here's our data frame. And then here's the columns that we want. And then I actually want to filter that more by just integer columns. And then I want to do describe on this. So if you read through this, it's a logical step of the recipes of what you're doing with your data. And I'm a strong believer in Pandas land that you should do this. If you don't do this in Pandas, you probably should. It will make your code easier to read. But it also forces you to think about the logical steps of what you're doing to your code, right? And you know, I get complaints about, oh, well, I don't want everything there. I want the intermediate values. And from my point of view, I don't really care about the intermediate values, right? I might check them as I'm going. You'll see that I do that. But my goal is I'm going to take the raw values, and I want the cleaned up values at the end, and the intermediate I don't really care about, right? And so this is going to take me from the raw to the cleaned up. Now, I do want raw data generally because my experience has been that after I do some sort of analysis, the boss comes back to me later and they're like, why did you say this, or what happened here? And if I can't go back to the raw data, if I can't trace that through, that becomes problematic, right? So having the raw data is useful. Having data that you haven't like manually cleaned up, that's useful. But having a recipe that takes the raw data and gives you each step, and you can trace through that if you want to, is certainly useful to answering your boss's questions. Okay, so back to this describe method here. One of the things I might want to do is look at this maximum value here. So the maximum value of this elapse, which is an integer column that's a 64-bit integer. Now, right now, it doesn't say 64-bit, it says F64. That's because this F64 is the type of the summarization here. It is not the type of the original column. A lot of people get that confused. This is the type of the summarization here, which is using floating point numbers because it has means in there. But the max value is like 10,686. So I probably don't need a 64-bit floating point number to represent that. Now this is only one column in there. You can imagine if you have a CSV file that has 100 integer columns and you're using 64-bit integers for all of them, and you've got 50 million or 100 million rows and all that, that could be a lot of overhead, right? So by shrinking that down, you can save quite a bit of memory. So we asked NumPy what the limits are that. You say info, integer info here, it gets you the ranges for an int 8. So this isn't going to work with an int 8, right? We can ask what a 16-bit integer is. This would probably work for a 16-bit integer. Maybe if I went for a really long ride, right, it's longer than 10,000 seconds. You know, if I did like a 24-hour thing, I might need to use something else. Maybe I could use an unsigned 16-bit integer to do that. Okay, so I'm going to try and change that type. So this is how I do this in Polish. Now, note what I did. I changed this to, instead of using the index operation, I'm using select. Okay, so select is a context here. And you know, one of the things I found after teaching Pandas to thousands of people is that one of the things that's confusing about Pandas is like, when do I use square brackets? When do I use parentheses? There's like an inconsistency. And one of the nice things about polars is it tends to be pretty consistent, right? And then I can see, like, you know, a lot of people who are programmers, they're used to using square brackets for index operations, right? It's like, that's pretty common. If you're a programmer, you say, like, what's at position I? You do a square bracket to do that. Maybe less common for people to think about, like, I'm going to do a square bracket with column names in there. I can see like that mapping kind of works, but also it is super confusing for a lot of people who are like, I don't want to be programmers, right? And so just the consistency here of polars, I think is nice. That like you can just say select instead of that, and that makes it really readable. Okay, and then I'm going to say with columns. So with columns is also this context here. With columns is similar to what the assign method in Pandas. So the assign method will update a column or create a new column. With columns does the same thing. So we're going to select the columns we want, and then we're going to say with a column called elapsed. Note that this thing in here is an expression. Okay, so it's not, so we have this df, this data frame that has all my data in here, but I'm not pulling out the data from that elapsed column. I'm saying there's a column that has this name, right? This is not pointing to the data. I'm just trying to make this clear. This is not pointing to the data. This is pointing to a column with this name. And then it says, I want to cast this to an 8-bit integer. Okay? And so what that should do is it should update the elapsed column and make it an 8-bit integer. Well, when we try and do that, we actually get an error here. It's like, no, you can't do that. It says this failed. And this is kind of nice here. It actually says like, it failed for this many of those values, right? And so we could go in there and like, oh yeah, the 8-bit integer goes up to what, 128. So yeah, it's not going to work for that. Let's try 16-bit integer, right? So I can throw that in there. I can do a describe after that. This did work, right? I mean, I can comment out the describe and verify that does indeed work right there. Okay, so that is my chain. And so I'm going to go through my process here, and my take on like the current state of AI is you have a lot of people who are like, okay, we got like these fancy deep learning algorithms or whatever. We're just going to take our crappy data and throw it into the deep learning algorithm. And because deep learning is so cool, it's going to do all this awesome stuff with it and give us a result. And it's often the case that like I can, through building some models and some analysis, I can do some feature engineering, and actually with like a logistic or linear regression model, outperform some fancy deep learning model with a model that's completely explainable. And so my take on like the current state of AI is like, I do kind of believe that this hand, going through each column, understanding what's going on with your data is super important. And so I get that there are tools that will like automatically do this, but I think for someone who's looking at like doing some modeling or doing some data analysis, it makes sense to kind of go through by hand your columns and clean them up by hand. Okay, so here is my chain up to this point. I'm limiting my columns there. Note that this is also important just from like, if I'm looking at my data, that select at the start. If you think about like a function oftentimes you want to put constraints about what comes in and what comes out. So you can think of that select at the start as a constraint about what's coming into my chain. Right? I'm limiting the operations to these columns here. And so someone who's coming to this could say, oh, I can look at the columns list and I can know exactly what this is working on. But also if that data frame, if the data changes, this has kind of a safeguard on it, that like a new column probably won't break it, right? Or if a column is missing, it will report on that very quickly. Okay, so after we do that, we see that we save a small amount of memory, right? But again, you can imagine with different data sets, that could be a significant amount of memory by doing that. In this case, it's not really anything. Okay, let's talk about strings for a minute. So I'm going to do my code here. So I'm going to select my columns. I'm going to say I want to select any string column in here, and I don't have any string columns in here. So this is one of the places where like arrow shines. Is like traditionally NumPy support for strings has been pretty poor, and generally when you're using Pandas strings, you're basically getting the performance of a Python list with Python strings in it. Has a nice syntax and that is consistent with Pandas, but you're not really getting much performance boost with the NumPy backend. PyArrow backend, you do get a performance boost with string and Pandas, but not with NumPy. And so this is a place where you can get some speed ups here. So I'm going to make a string column just to demonstrate some of the things that you can do with strings. So you'll note that I'm preserving the chain that I'm doing. And this is how I often build my code, right? I start with the basics, but then I add things to my chain, and I keep building onto my chain. And as I'm adding something to my chain, I'm validating what's coming out of that. A lot of people will look at my code and they're like, oh, that's horrible code. It's too long or whatever. How do you debug it? And it's like, I debugged it as I was going through it, right? I think it's weird that like people don't say the same thing about SQL queries. Like you see some long SQL query and someone's like, awesome, that's a cool SQL query. No one says like, how did you debug that? Well, you debugged it by like building up the query, right? And running it. So I think it's similar for these queries. So I'm just building this up, right? And so I'm using inside of with columns, I'm saying course is equal to, and then I'm saying PL list. So this is going to make a literal column here, and this is the name of the column or the course that I crashed on. It's called maple syrup. So there is now a string column in there called maple syrup. Okay, and let's do some operations on that. So I'm going to say with columns here, and I'm going to say take a column named course, and then look at this. This does have str, so much similar to Pandas. Pandas has an str accessor to allow you to do string operations. It does have str. The operations aren't named the same as Pandas, but there are a bunch of string operations in there. Okay, so here is to uppercase, and if I scroll over here, you can see the alt name here is uppercase. Now, a couple of things to note. You might say, you've got a with columns there, Matt. Why did you make a new with columns? Right? Did anyone think that? Maybe not. Okay. Well, I will answer my question that no one thought of. Inside of a with column, remember, polars says we are going to max out your CPUs. And when you do a with columns, it's going to say for every column you're creating, I'm going to put that on a different CPU. Okay, so these are all done at the same time. Contrast that with an assign in Pandas. If you use assign with Pandas in the same parameter list, you can use a lambda, and you can refer to a column created in that same assign, because Pandas is going to go through those in serial. Okay, so I can't put this alt name here inside of this with columns because it depends on course being created. And if we're creating those at the same time, it's going to complain. You can change that code and run it and confirm if that is indeed the case. Okay, so here I'm just going to make a column, just show you like what's available here. Hopefully you're familiar with DIR, it lists the attributes of a Python object. So I'm just making a column called blank, and we're going to look at the attributes that are follow str, and there's the attributes that follows. So you could do a similar thing with a Python string, or you could do the same thing with a Pandas series and look at the str attributes. There's a lot of similar things. Some of them are named the same, some of them aren't, like 2 uppercase. Python nor Pandas use 2 uppercase. So they changed the API, but I think the API is different. So this is why you can't just take your Pandas code and run it as pullers. But I think the intent is to make the API clear. And if you're in Jupyter, you can pull up the documentation for this. Documentation compared to Pandas seems to be a little Spartan. So I think one of the places where Pandas actually is really good is the documentation. It tells you what's coming in, it tells you the types of things, and it gives a bunch of examples, and it says, see this. This gives you an example, and it's not that like you need a bunch of documentation here, but I'd say, if you're comparing documentation, Pandas probably has a slight upper edge on that. Okay, questions up to this point? Okay. Okay, so at this point, I've got this chain here. I want to convert times. Times are one of those things that are super fun to play with. So similar to Pandas, we do have a DT accessor, but again, those names off of that DT accessor are different. One thing to note, at least right now, and if someone has a solution, maybe someone has some RAG thing that does this, but like, I haven't found that the AIs, at least the publicly available AIs, like ChatGPT or Claude, are good at pullers. So if you take your Pandas code and you say, hey, convert this Pandas code to pullers, it will certainly spew out a bunch of code, but it's probably not the case that the code will work. There's probably some RAG or tuning that someone could do, but right now the AIs aren't good with that. And another sort of, I guess, problem for software people in general is like, if people are like, well, I'm just going to use ChatGPT and ask all my questions to ChatGPT, and I'm not going to use Stack Overflow anymore. Well, where was Chat getting all of its training data? Probably from Stack Overflow, right? And if there's no training, like the only training data for pullers is the pullers documentation, basically. I mean, there's some in Stack Overflow, but there's not a lot of training data in there. And now you have like this, like, okay, no one's going to make new training data. They're just going to ask AI what the answer is. So I don't know what's going to happen there. I guess it'll get figured out. But like right now, Chat is not good at pullers, and it's like I don't see it improving dramatically. Anyway, end of rant about Chat. Okay, so we're going to go back to dates here. We got this time column. I want to convert this to Denver time zone because I live in Salt Lake. So I say .dt, and then I say convert time zone, and let's just run that. And you can see, oh, look, you can actually see the type right there. It looks like that worked okay. Again, convert time zone doesn't exist in that name exactly. It does not exist in Pandas. Let's just make a column here, and these are all the attributes on a column. Right, so these are all the things you can do on a column. There's Pandas has like 400 things you can do on a series. I think there's, 260 here. So not quite as featureful there. We can look at like, here's the date time things you can do, and there's 70 things that you can do with the date off of that as well. So similar ideas to Pandas, but again, spelling might be different. Now, another thing you might want to do with your data is figure out, is it missing or what's going on with that? So we got a couple things that will allow us to help with that. Now, another thing to be aware of is what does Pandas use when something is missing?
It's generic.
Yeah, uses nan, right? Okay, do we have any mathematicians in here?
So,
David's a mathematician. What does nan mean?
not a number.
Yeah, does nan mean missing?
Well, it depends.
Okay, it depends. If you're a Pandas developer, nan means missing. But the traditional meaning of nan is not a number. Okay, so polars actually has the concept of not a number and null. So if something is missing in polars, it's null. If something is nan in polars, it's nan. And it's possible to have a column with numeric values where you have both nans and nulls in it, where nan is not a number and null means there is not an answer here. There's not a value in here. So just be aware of that. Pandas sort of conflates the two, and in fact, if you look at like is NA and is null and pandas, they call the same method. Not the case in polars. Okay, so let's do this. There's a null count in here. We'll do null count. This summarizes those. You can see like speed between has a null value. Rolling travel has 4 null values here. Let's select where those missing values are. So I'm going to say dot select. And in this case, instead of just giving a list of columns, I'm going to say, let's make an expression. So I'm making this expression. I'm going to say, take the rolling between column, because if you look at rolling between, which is up here, there's 5 missing values. And where is that missing? Is null, right? And if we look at that, we get back this thing. So this is a data frame. It has a single column. It's a Boolean column. You can see like the first 5 values are true, and probably the remainder are false because there's only 5 missing values in there. Now this is kind of the cool thing here. You know, you could do something similar in Pandas. You could say, you know, well, Pandas doesn't have a notion of null, but you could say is NA in Pandas, or you could say is null, right? If you're assuming that nan and null were the same, but in polars, what we can do is all we have to do is we can change this select, this filter here, and the rest is the same. And instead of showing us that column with true false values, this will show us where those values are missing, right? In Pandas, we'd generally make like a Boolean array that says where is this missing, and we'd stick this into like an indexing operation to filter those out. In polars, you just change the select to a filter, and there you go. This is the 5 rows where rolling between is missing right there. Okay, let's look at nans. We can say, so there didn't used to be a nan count, which is kind of weird to me, but anyway, but you can kind of get something similar here. You can say like, take the numeric column. So remember, CS is this module that's the selector module and just has generic utilities for selecting here. We're going to say is nan, and then we're going to sum those up. And this gives us something similar to what I think that nan count should be. And you can see that like in the velocity, there is a nan value. So again, this is not a missing value. It means that somehow, like you did the division by 0 or something like that. And look at this. All we have to do is we can say, okay, well, let's select that, right? We can say select is nan. And there it is. It's the true. And if we wanted to view that, we change that to a filter. And there is the row where that is missing, right? You can see there's the nan right there. Okay, so I'm not going to step through like cleaning up nans and missing values here. Suffice to say, like you could have a whole semester-long course about dealing with missing values and whether missing values are missing completely at random or almost at random. My general advice to folks is like find a subject matter expert and ask them why this value is missing, and then think about it and figure out, do we need to drop rows? Do we need to drop columns? Do we need to add indicator variables? Do we need to impute? The answer is one of those unsatisfying, it depends on what you should do. But at this point, we're going to say I kind of cleaned up this data, right? I mean, I got those nans in there, but again, I'm going to just sort of let those be. And what I like to do at this point is I like to take this chain of code that I made and just throw it into a function. And again, this is one of those places where I think a lot of scientists, or I don't want to be programmer types, kind of like, what's a function? I don't want to deal with a function, right? And this is what normal software engineers do. They write functions. They don't write things at the global level, which Jupyter kind of encourages. And again, admittedly, that's nice, but you know, we can stick things into functions, and it makes things like testing really easy, or reuse really easy, or taking things out and putting them into production a lot easier, right? So what I like to do is I make this function that has my recipe to clean up my code, and then I take this function, I stick it up at the very top of my notebook. So in my notebook, I load my raw data, and then in the cell right below that, I have the function to clean it up. So I don't have to come back to my notebook and say, oh, I need to run these 50 cells to do these 50 things, and I need to make sure I do them in this order. Oh, I forgot to run this cell. Now I don't have any of that. I just load the raw data and clean it up, and I'm done. So that's a practice that I like to use. Let's just run this and make sure that it works. It looks like it does work. So again, I can take that and stick it up at the top. I talked about chaining, right? This is this flow style programming.
Good.
You know, there is this notion of Demeter's law in programming, where like you don't ask your friends about their private parts, which is like coming from C++ private parts. But you don't like reach in and access private parts. You like call functions or methods and get things that way, right? This is not a Demeter's law violation, because we're not reaching into private parts here. We're just getting a result, and generally these results tend to be polars, data frames, or lazy frames, depending on what we're doing. We're just going to subsequently do other operations on them. So let's run this here. I'm just going to run this. This should say this is a Parquet file, and okay, so now that I've made this Parquet file, I'm going to show another feature of polars, and this is the laziness. So I've been doing everything in eager mode right now, and eager mode just evaluates it when you tell it to do something. But if we change, instead of like read Parquet, we change this to scan Parquet, we're going to go into lazy mode. So let's run this. And instead of giving me back a data frame, what this gives me back is a query plan, right? And this is saying, these are the steps that I would do. And you can actually see, like, it's this, if you understand the recipe, like you can translate this recipe into like what's going on here, right? But there is a query engine under the covers that has smarts that knows how to optimize things to like make it run quickly here. I'll also say things like this, where it's like, okay, let's assume you have whatever Parquet or CSV file, you're doing some filtering, you're doing some column filtering and some row filtering, and then you do some group by, and then at the end you only have like 3 columns. You can tell polars to do that, and when it's reading the CSV file, it will skip over rows, or it will not read columns that aren't being used, right? So it has smarts to be able to do that, where you kind of get speed improvements, but also memory improvements by those capabilities. Okay, so when you have something that's lazy, what you do is you just tap on this collect, and that says, okay, run the plan, right? And then when you run this, it looks like that works. Now, I'll mention this because I collaborate with NVIDIA, and we've got a bunch of NVIDIA people here, but I think what NVIDIA is doing is actually pretty cool. They've done similar stuff for Network X, and they've done similar stuff for NumPy and Pandas. In fact, I once taught a GPU course to a client, and I took my Pandas content, and basically it all just worked with GPUs because of their work. But what you can do is you can say, okay, I want to run this, and instead of running it on the CPU, I want to run it on a GPU. Now, admittedly, I'm on a Mac here, so this won't work. But if you were on a machine that had an NVIDIA GPU, you could say run this on the GPU. And oftentimes, I've seen in some of my testing like a 10x speed up on a GPU. So polars is already really fast. You can get an additional speed up by running it on the GPU. The cool thing about what NVIDIA is doing is, we talk about like compatibility, and I talked about like the Pandas API, and there are some libraries that implement the Pandas API so much so that they implement the bugs of Pandas APIs. And there are other libraries like Spark, where it's like, this is the Pandas API. And does anyone here use Spark? Okay. You take your Pandas code and just change import Spark as Pandas, and does it run? Okay. I get a bunch of shaking heads, right? So it's Pandas-like, but it's not the Pandas API. Right? Where this is the polars API, right? My code doesn't change, and I've gone through like fancy examples from my book, and they just work on the GPU just by changing that. Okay, so some people, they really want those intermediate variables, right? They're like, but what about the intermediate variables? How do you debug that chain? And again, my point is like, I'm debugging the chain as I'm building it, right? and I'm putting in safeguards to check it, but it might get broken over time, or maybe it stops working, right? But I would rather have a single piece of code that shows me every single step than 50 cells that do different things, and like walk through those 50 cells and figure out what's going on. Now, admittedly, there are some places where chaining doesn't work. Not everything works in a logical way. But oftentimes that constraint of like forcing you to think about things in steps forces you to write things in a more logical way, in a way that makes sense. But sometimes you have like two things that you need to bring together, a little bit harder to do that in a chain. One of the things that helps is you can use the pipe method. The pipe method is a generic method that says you can throw any method in here and it can return whatever it wants, right? So we can factor out more complicated things and do pipe methods. And I've seen like social media spam where it's like, well, I just learned about the pipe method. I'm going to make this chain of like pipe. You can do that if you want to. I don't know that necessarily adds values like with a ton of indirection there. But here's some places where I think it might be useful. So here's a pipe, and I'm just using a lambda here. Again, this is another place where like people are like, I don't like lambdas, they're confusing. It's like, okay, if you're a newbie, they might be confusing, right? But if you take 5 minutes to understand what's going on, they're actually really useful because you have the logic directly there instead of the logic on some other page somewhere. So here is a function, right? You can pass into pipe something that takes a data frame. So this takes our data frame here, and I'm just going to print the shape of this and use a short circuit to return the data frame. So because I can't put an if statement in there, this is kind of the hack to return. You can have the pipe return whatever it wants, but if you want to keep working on the data frame, you should return the data frame. So what I'm going to do is just print the shape of it. And this is super useful if you're doing like joins or merges, right? You can look at the shape before and after, or if you have complicated operations or filters, and make sure that you don't have some combinatoric explosion or something going on. You can also put in logging in here. And here's one. I'm going to use this get var. So look at this. I'm going to call the get var. I'm going to pass in this argument called intermediate as well. And if you look at the function for get var up here, it takes the data frame as the first parameter. That's kind of the thing. It has to take data frame as the first parameter. You can have other parameters you want. This intermediate is going to be passed as var name. And then we're hijacking the built-in globals function to just make a variable that points to the current state of the data frame. So if someone really does want that intermediate state, you just stick in a pipe with whatever variable you want, and you have, this works in Pandas too, and you can have that. So let's run this here, and that looks like it worked. And then I can come down here, and you can see like, here's the shape of it, right? This isn't doing really anything interesting with the shape, but you, again, if you're using like merges or joins, that could actually be quite useful, or you can do logging. But here's the intermediate variable right there, right? If you really did want that intermediate part. Okay, questions or comments up to this point?
Can only test the about safety is the docs so or it's going just like this. It's out of classifications. That would be fast.
So the comment is you only get speed ups if you're lazy. Is that, or question? Yeah. I'll say this, like Polars is going to do things as fast as it can, right? So it can do a with columns and like maxing out your cores with the with columns, right? But if you're not doing the lazy plan, there are certain operations that can't optimize as much as you maybe could have otherwise. So it can do additional operations, additional optimizations.
Yeah.
Okay. Another rant here. So I often see people are like, well, I just learned about like in the Pandas, like the apply method. You want to use apply? Okay. So apply is like this thing that I see all of this bad content out there, which is like, I think why AI is kind of bad at Pandas code too. Because it's like, I just learned about apply and I'm going to make all these functions that basically pull things out of the sandbox, do something really slow, and then stick it back in, but it's using apply, and apply is confusing and cool, so that's cool. And it could be cool, and there could be cases where like apply is useful, like generally in Pandas 1, string operations were slow anyway, so doing apply with those might make sense, but oftentimes all things that people are doing in apply they should just be doing inside the sandbox. Okay, so generally when you're doing apply, and the Polar's version of that is map elements. We're going to map a function to each element. That's a slow operation. Okay, so here's just our code. This is what we had up above here. And so this Strava data is very world-centric, and I live in the United States, so I don't understand what meters are. So maybe I want to convert meters to feet, right? And I asked ChatGPT, I'm like, oh, make this function to convert meters to feet. And so it says, okay, here's a function that converts meters to feet. And then I'm like, okay, well, I've got all this meters thing here, so let's map every value in there to meters to feet. And it's like, okay, cool. Looks like that worked, but look at this, there's this pink stuff here. And let's see. Actually, if you read this is one of those warnings that I'm not going to ignore, I'm gonna read it. Map elements is significantly slower than the native expressions API. Only use if you absolutely cannot implement your logic otherwise. And it actually gives you, like, you could actually probably do this, elevation times this instead. So that's kind of nice, right? It says, like, you're doing something probably dumb here. And so we can get around this. This is still in the sandbox. If you call the function, and you can pass in the expression here just by doing that. This gives you the same result, but doesn't complain. You can actually do it with a pipe as well. That will work. It will pass in the whole column in there and multiply the column by 3. That works as well. And then, you know, I can just benchmark these. But basically, the gist of this is that, like, if you stay in the sandbox, things run a lot faster. If you go outside of the sandbox, you get flexibility, but things slow down quite a bit because you're being slow here. Okay, so let those benchmarks finish, and this one spits out all of this warnings here. But somewhere in here, there's actually how long it took, but it, you know, on the order of like 20 to 30 times faster. Okay, so my general benchmark caveat, right? This is very small data, and do I really care if it took like 500 microseconds or 900 milliseconds, or, you know, actually did 900 microseconds. So I really can't tell the difference between those two, right? For this small data, it doesn't really matter. But you might be the case where you have very large data, right? You've got a couple million, billion rows, and you want those to run fast, and you know, if it takes 20 times longer, that can be problematic. Okay, so oftentimes folks will ask me, like, what's faster, this or this? And you know, oftentimes there is, like, this is a better way to do things. Like, map elements is generally a bad way to do things. Sometimes it is one of the only ways, but oftentimes it's not. But I would say, if you are benchmarking in general in Python land, just make sure that you're benchmarking with the size of data that you're using in production. Because there are a bunch of libraries where you have smaller data. As the data size changes, the results of the benchmark might be impacted by that as well. Okay, our last section here is on aggregation here. So I like to say that aggregation, these are the questions that your boss has for you, right? And so, you know, if you worked at a candy store and the boss comes in and says, how are we doing today? And you say, well, Susie came in and Susie bought a lollipop and then a piece of gum and then a candy bar and then another piece of gum, and then Billy came in, and you go through all these people and their individual purchases. Your boss is going to be like, actually, just be quiet, I don't want to talk to you anymore, right? What your boss wants to know is, so there were 25 people who came in, they spent $562, right? If you tell your boss those stories, that's generally what they want. We call those aggregations, right? Instead of the individual details, we're collapsing those values. So these are things that can be confusing both in Pandas and Polars, or at least take a little bit of, like, capturing the syntax, understanding the syntax. But once you get used to them, you can do some pretty cool things. So let's say that I want to know, like, what is my speed or maybe my distance by 10-minute intervals, right? And so here's my code here. I'm going to take the raw data. I'm just going to call that tweet there. And then I'm going to say, I'm going to call group by dynamic. So in Pandas, there's a group by, and you can pass in this PD grouper. Anyone use PD grouper? Super useful. You can get these offset aliases. You can say every 2 months or every 3 days or something like that. To do that in polars, we use this group by dynamic. And so you can say, this is the index column. Now again, there isn't an index in polars, but this is say, whatever I want, what you put on the left-hand side, that's what I want to put on the left-hand side. I want time, but I don't want it based on every second or every 2 seconds. I want it based on every 10 minutes. Okay? And then I'm going to say, let's do an aggregation. And here I'm building up an expression here. I say, let's take for every 10-minute group, I'm going to take the travel column, I'm going to take the last value of that and subtract the first value. And so that travel should be how far they traveled during the 10 minutes. And then speed is going to be doing the travel calculation again, and then dividing that by the total number of seconds that elapsed during that. And then after that, I'm going to make a column called miles per hour, and I'm going to convert meters to miles per hour, because again, I don't understand what meters per second means because I'm US-centric. Okay. So one more thing to note here. So polars is smart about some things, right? If you make a bunch of columns, it can do those in serial. You'll see a lot of benchmarks where it's like polars was faster than this, but it's like it might be twice as fast, but it's something that took like 1 second or 2 seconds. So it's like, is it worth porting all of your code from Pandas to polars for like 1 second or 2 seconds here or there? Maybe not. But where you can get a big speed up is when you're doing these aggregations. Because what's going to happen is that every group is going to run on its own core. Okay, and Pandas doesn't do that. So generally, I say if you're thinking about moving to polars, find where Panda. If you're starting off with a greenfield project, that might make sense, right? But if you have existing Pandas code, it might not make sense to throw that all out. But it might make sense to say, oh, we know that this group by operation is slow. Let's push it into polars and make it fast. And if you're using PyArrow as a backend in Pandas, you can get a zero copy to polars. We just talked about the pipe method. You make a pipe method in Pandas, convert it to polars, run your group by, convert it back to Pandas, which is a zero copy, and put it back into Pandas. Your colleague won't even know that you use polars, right, if you use pipe. That might be something that you could speed it up relatively easily. Okay, so again, we don't have an index here, but this left column is time. You can see that it's every 10 minutes or so. We have how far we traveled and what the miles per hour was between those 10 minutes. Okay, and then oftentimes, we say that I say that your boss doesn't want the details; they want the summarization. And I also say your boss might say they want oftentimes people are like, I want the data, just give me the data. If you're giving them an Excel spreadsheet, like if you're an analyst and you're like constantly giving someone an Excel spreadsheet, I think there's a problem, like something along the way is getting dropped, and like you shouldn't be handing around Excel spreadsheets, personally. But people are like, I want to see the data. Humans aren't evolved, like we haven't evolved over millions of years to like sit around the campfire and like, oh, look at this table of data here. Like, oh, wow, that's awesome. Oh, look at that. On line 50,000, look at that, right? We haven't evolved that way. But we are evolved to see differences, and oftentimes with a good visualization, you can tell a story very quickly. And so these aggregations lend themselves to visualizations pretty good as well, right? So here I'm going to say just tack on this .plot.bar. And recent versions of polars are using the Altair library to do visualizations. However, if you want to use Seaborn or Panda, or not Seaborn, Seaborn or Matplotlib or Plotly to do visualizations, polars works with those libraries as well. So here you can clearly see like, oh, look, my miles per hour. I think my crash was somewhere around here. 707 was, I think, the time of my crash. Maybe I want to look at like uphill versus downhill. In this case, it's not a dynamic group by dynamic, so I'm not grouping by time. So I'm going to make a new column that's like, am I climbing? I'm just going to pull out the elevation column, do the diff, and see if the diff is greater than 1. If I went up. And then I can group by whether I'm climbing or descending. And then I'm going to say, okay, let's look at the distance, climbing versus descending. And something looks like this. So when I was climbing, my distance in miles was 6.1. My descending was 5.4. That's because I crashed, and then I didn't make it all the way to my house. I actually went to the hospital. And so my descending is not the same as my climb there. And yeah, and then you can throw a visualization on this. A bar plot might be an appropriate visualization here. Okay, so this is grouping. Very similar to Pandas, but again, syntax is slightly different. Okay. So I've got, that is what I had. Let me summarize here, and then I'll take some questions, and then we'll do a book giveaway as well. Okay, so thank you for listening to my rant today. Hopefully this was insightful to you, or at least gave you a feel for some of the pros and cons of pullers versus some other libraries here. Generally I am of the opinion that at least right now I want to manually go through my data and clean up that data. The more I know about my data, especially if I'm doing like analyst or if I'm doing machine learning models, the better I can make my models. Chaining, again, this is one of those things, especially like almost everyone in here is using Pandas. If you haven't used chains with Pandas, this is one of those things I say, try it out. Like you might say that looks really icky, but generally what I get from people who I work with is like, I tried this out and it like completely changed how I write Pandas code. Now with pullers, you don't have to chain, but if you don't chain, you don't get the speed benefits of it, right? If you chain, you can do the laziness, and then you get additional speed benefits from chain. So I would say try it out for Pandas. Generally, it forces you to think about your code in a better way. It makes it really easy to put it into a function. The function makes it really easy to put it at the top of your notebook. You can come back to your notebook tomorrow, in 10 days, in 3 months, and it will just work. You don't have to fight through 50 different cells. Generally a good thing. Doing apply or map elements, only use that when necessary. Map, that's going to be slow. Aggregations are super powerful. So again, these are the things that your boss wants. So I think it makes sense to master how to translate what they want into either succinct data or a visualization that allows you to visualize what's going on there. Okay, thank you for listening. I'll answer questions and then we'll do the book giveaway.
Yeah, I was just wondering if you did find out how long you were out for.
Yeah. Oh yeah, how long was I out for? I was out for 1 minute. And yeah, at 1 minute, I landed on my face basically and tore off the bottom of my chin. And so I had 10 stitches on the inside here and a few on the side to like pull it back up. I'm doing okay. I have some nerve damage, but I'm okay. No teeth lost, so I'm happy about that.
Did you realize that because the distance was 0 miles per hour, Cameron?
Yeah, I did a visualization and there was a little flat line in there. And then I looked at the timestamp when someone was texting me and said, "Where are you?" and lined those up. And it's like, oh, I didn't move for a whole minute and someone was texting me, asking me where I was. And I didn't remember. All I remember is flying through the air and then thinking, I need to take a selfie to see how many teeth I lost.
So very nice tutorial. Thank you. I'm curious if you comment a bit about the design decision to go away from having an index in the polars data flow. Because I think one of the things that, in Pandas, it's a really useful thing, and it's been extended in Xarray because you could do things like time series resampling and the various other kinds of specialized operations. Those things still exist in polars. Is it find, funky ways of doing that, or?
Yeah, so the question is like, can you comment a little bit more about the decision to remove indexing and because it comes in useful in places in Pandas? Yeah, I've got like an example in my book where it's like doing some math operations where it actually, in Pandas, if you have like two data frames and they have, overlapping indexes, those will align and the math kind of works, and sometimes that's really useful. And Polars doesn't have that, right? So you need to like step through some hoops of like adding in a fake column to like merge that. But as far as like, the time series stuff, I haven't really like, it does have pivoting and the time series has, the group by dynamic, which gives you basically that resampling capability. So I haven't found a lot of places where I've been missing it. Like you said, it does come in useful for like aligning things. I think, a common complaint or confusion I see with folks is like when you do multiple groupings and you get like a hierarchical or multi-index, people are like, what is going on here? And then people try and like do some like loc on that. And it's like, how do I do a loc on a multi-index? And super confusing for folks. Or similar with like hierarchical columns, it doesn't support that. So
10.
I don't know. I think in general, I really like the design decision made by Polars. I guess I would say if you have a use case where it's like, oh, this is really painful, you might want to like bring it up to the Polar folks. Like I said, they're super responsive and they might have a better way to do something.
Thank you, John. Question about GPU. That only work with NVIDIA or the like that?
Yeah, the question is GPU support is for NVIDIA devices.
Answer. So I kind of I run into the Pandas all the time is I need to effectively treat rows differently. Like I have a complex conditional, it's Thursday and sunny and whatever, do this function for these rows, but a different conditional for other rows. What is the Polar's sort of equivalent?
Yeah, so the question I'm going to summarizing is say this right is like I have an if else that I want to do conditional application. So Pandas 2.2 gave us like case when, right? Which I think actually does if then like or kick. Pandas 2.2, which maybe it's not case when, but one of them has like a case when, which is actually like Pandas had a when method on it, which is like or where, so not when, where. And it's like on the series, if the series, then you pass in a conditional, and if the conditional is true, you use this other value. Otherwise, you use the value of the series, which is kind of like an else without the if. Like you have to stick the if in the series first, which I think is kind of weird, which is why the Pandas people like rectify that. So there is like a natural syntax for Polars, if else. The name of it escapes me right now, but
When that?
yeah, I think it's when then. Yeah, when then otherwise.
Yeah.
Yeah. So I think that is actually clear to you. It's like generally in the past with Pandas, I would actually use NumKey select, the NumPy select, just because it like lets you have like, here's a conditional and here's the response for that. Here's another conditional, here's the response for that. Here's another one, here's the response for that. And here's the default value. Yeah, Pandas, like also the default value is kind of broken in their new one. Like to give it a default value, you have to make a series with the index. And yeah, it's weird. So yeah. Okay. Yeah, I don't know if that helps, but like there is support for if else in Polars, which I think is is more natural than the Pandas. At least I like the API where they're to the back.
Is there a is there a way to like decide what to keep in memory with polars, or let you choose? You mentioned it's from like media size. Yeah.
Mm-hmm.
Like, would it let you choose? This is the part of the type data that I want to see just on page data. I was gonna use it more to this other part of my day.
Yeah. So the question is, can I manage what is streamed in versus not streamed in to Node? No, there isn't. Not that I know of a way to manually manage that. It's just we're going to use lazy data frames, and lazy data frames will stream in memory, and then when stuff happens, it pushes it out to disk. So it tries to be smart about it, but I don't think there's a way to manually control that right now.
One person, it's not common operation within in Pandas that are swing operation Pandas. That is used to be very manually inefficient. Like use all manually to this. So I'm sure that this big code, you mentioned that since file collaboration with this the project for one code handling it. So that's also applies to like strong operation. That will work, yeah.
Now the question is, what's the optimization technique used for joining on pullers? I don't know off the top of my head. Richie's here. You should ask him. This and can go into details on that. But I don't know off the top of my head. Yeah.
You should. You don't say bye. Please. You made a few comments about pullers dealing with the should space theory. Can you comment a bit about its synergy with libraries that from the liar can notify or Cycon really as it goes to the Legend Cloud isn't the stakes hold that they wrote. And
so I think the question is, if I'm using Python or NumPy, how does that work?
well, if you're doing something in machine learning work with libraries like PyTorch, scikit-learn, and then NumPy, I want you to comments, but I like to kind of originally fold instead those told this.
Okay, so maybe I'll rephrase this: general compatibility of polars versus the third-party library, other third-party libraries. Yeah. So again, one of the nice things about Pandas is that Pandas has been around forever, and it's kind of the de facto DSL for data scientists, and it's also the de facto interface for most libraries, visualization, at least tabular, machine learning, otherwise. There are efforts with this data frame API to abstract that out. And there are a lot of libraries that, quote, just work with pullers, but there are also a lot of like edge cases and libraries that don't work with that. And like when I wrote my book, I ran across a few of those, and doing work with clients, sometimes I'll run across a few of those, and I'm not sure if that's because no one else is doing that. I'd like to think that like some of these things that I'm doing aren't so outlandish that people wouldn't be doing them, or aren't too dumb that other people might not be doing them, or people just aren't reporting bugs. But I will say that there are some corner cases where pullers might not work. Having said that, again, because everything kind of just works with Pandas, worst case scenario, you throw it back into a Pandas 1 NumPy back data frame, which is not zero copy because it's not PyArrow. And that's sort of everything works with Pandas 1, right? Even Pandas with PyArrow, there's use cases or places where you run into issues where stuff doesn't work. I would think does, but doesn't. So that's my feel on that, sample size 1, but I feel like I kind of try and test out a lot of the familiar libraries. I don't know if that helps or not.
Yeah.
And so again, like old, slow, boring technology, Pandas kind of works everywhere, right? Faster, more bleeding edge, might be some incompatibilities, but again, the developers, at least on the polar side, are responsive. Sometimes it's the other library that has to be responsive, and sometimes like I filed bugs for other libraries and I'm like, polars.
design into the
Okay, let's do a book giveaway here. So what, I'm gonna give away the book and we'll just do this by row. So since we're at Python conference, this is row 0,
Please put me down.
row 1, 2, 3, 4, and I guess we'll let this be 5. Okay.
concept. Actually,
Okay, so we'll use Python, we'll import random. And what do I need? This is the trick question here. What do I need to put in here?
okay, so
6.
so like 6
6? Why 6?
since those
It's the half open interval, right? So we use 0, we include 0, but we don't include 6, right? So we're gonna put 6 in here. And 2, which is the 3rd row. Okay, raise your hand if you're in the 3rd row. The 2 row. Okay. Keep your hands ready. I'm gonna count you up. Okay. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, so what do I need to put in there?
Wait, you didn't start at 0.
Yeah, I didn't start at 0? Yeah. Okay, so I need to go from 1 to what? You were 17?
Yeah.
So what do I need to put in here?
18.
18. Okay, good.
The int is inclusive.
Oh boy. The comment is rendered as inclusive. My brain's gonna explode. I only have so much minutia that my brain can hold. Like the consistency. Okay, 5. 1, 2, 3, 4, 5.
Yeah, you.
Awesome.